What's up, guys? Hey, Devs here. You know, another day, another LeetCode problem. Um, I'm kind of tired today. In this video, we're gonna do I think it's day 27 now. We're doing a problem 102, binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. So it wants us to return 3 and then 9 and 20 because that's at the first level right here. Then it wants us to return the next level. So we'll return the list of the first level and then a list of the second level values. So how to shadow, he's currently chewing on a towel. And then the last level, which is 15 and 7. And it wants us to go left to right. Um, so for this problem, you need to do breadth first search, or so that means is you check, you have like a queue of nodes, and you check it, and then you check everything it's linked to, and then you check only those linked, and then you check who they're linked to. So the way it would kind of work is like you store or have a queue. So we put 3 in the queue, right? And then we would check 3, and then we would add everything that 3 is pointing to. So we remove 3, and when we remove it, that means it's been checked. And then we would add 9 and 20 next into the queue, right? And then we would check both of these values. So 9 has the nulls. 9 has nulls on both sides, right? Um, 9 has nulls on both sides, right? So none of its values get checked. So it won't get added to the queue. But 20 has values. So 20 adds 15 and then 7 into its queue. Stop it. You're chewing into the carpet, buddy. He looks up when you go to I'm sorry for that. But once these get popped, they're removed from the list. He's so playful right now, Ben. Sorry about the dog. He loves get riled up as soon as I'm going to record a video. So we'll just go ahead and implement this. It might make a bit more sense once we have some code on the screen. But the first thing we need is we need a list of lists that holds integers, because that's what we want to return, right? We're just going to call this the solution. Is this what our solution is going to be? We're going to make it a linked list, and then integers. And then first thing we want to check is if root is equal to null. We'll just go ahead and return solution as an empty list. And then after that, we can go ahead and make our queue. So we're going to make a queue of tree nodes. And we're just going to call that queue. And then we're going to set that equal to a new linked list of tree nodes. Just like that. And from here, we want to add our first node, which is the root, right? Q.add as root. So this starts off our breadth first search traversal. He's got the zoomies right now. Shadow's just running all around the house. So while this queue isn't empty, we want to loop. So if it is empty, and then we'll add the not operator. So while it's not empty, we'll be sure to loop and check each level. And at the end, we want to return the solution. So for each pass, we want to do we're going to create a list of integers, and then we're just going to call this, what is it, just the level because this list will hold the level of the nodes, the values. And then we're going to set that equal to a new linked list of integers. Call the constructor. And then we're going to get the queue size. And queue size is equal to queue dot size. And then we want to loop over the queue for the size. We're going to be adding stuff to the queue, but we want it to only loop for the size of the queue before we go into this for loop, right? So kind of what I mean here is each iteration, this queue will only hold the level. So the first, it will hold the 3, and then it will add 9 and 20 next. But it'll only loop once since it only has one node inside of it. So it will only remove the 3 node. And then the next iteration of the while loop, the queue will have these 2 nodes. So queue size will be 2. And then it will loop over these 2 nodes, and then if they have any nodes that they're pointing to on the next level, it will add those into the queue. So if you imagine 9 had 2 nodes, the queue size would be 4 next time, and it would loop over all 4 of these in the for loop. So that's what we're doing here. And then in here, we want to go ahead and erase that. And then we'll make a tree node. I'll just call this temp node. And this is going to be equal to queue.remove. And then we want to level.add the temp nodes.value. And so this for loop will loop over every node at the level, because the queue before it reaches the for loop is only the nodes at the level. And so this will add the values like we want here. Down here at the bottom. So we just want 3, and then we want a list of 9 and 20, and then we want a list of 15 and 7. And so that's what this is doing here. So this for loop will add the value of the current level, because the level is going to add the temp node value, because the queue only has the nodes at that level. And then this if statement will add all the nodes that are in the next level, and then it will break out the for loop before it checks them, and then the next iteration around it will go ahead and add those. So we'll do temp node dot left. We want to do left first because we're doing from left to right, not right to left. Then temp node dot left. If it does not equal null, we can go ahead and save a little bit of space here. Queue dot add, and we want to add the temp left. And then if temp node, we'll do the same thing for the right node. So if temp node dot right does not equal null, so this just means it has a node there that we can store. We'll add that into the queue. Add temp node dot right, and then this should be good, right? And then at the end, we're just going to go ahead and add our level into our solution. So solution.add a level. And then we return solution. That should be a-okay. If I didn't forget a semicolon. Okay, I don't think I forgot a semicolon. Queue size is not a function. Run it. Accepted for all the test cases. Go ahead and submit it. if it gets accepted. 1 millisecond beats 89%. I don't know what the 0 millisecond time is. Maybe it's just in a faster language. I'm not really for sure. It does have a O of 1 time complexity and then, or O of n time complexity, because it does this loop for every node, and then it does this loop for every level. So for sure does this block of code for each node. And then it would have a space complexity of O of n, because the queue and the list is only as big as the nodes, right? So it has a space and time complexity of O of n. And we can go ahead and walk through our solution one time for the first. So we have our list. It's empty right now. And then we have our queue. And I guess we'll do this first. First in, first out. And then we have we'll just start from the top. So we make sure the root is not null. 3 is not null, so we don't return anything. And then we go ahead and create our queue, and that's what this little arrow means. And then we go ahead and add the root into the queue. So we'll put a 3 here. We'll circle it so you know it's a node. And then while the queue is not empty, you see there's a value 3 there, we'll go ahead and jump inside of the while loop. And then we create another, so this would be our solution. And then we have our level list. And we go ahead and create the queue size, and the queue has a size of 1 right now. So we can do queue size, and that's equal to 1. So we'll only loop over the for loop one time. And then for I equals 0, I is less than the queue size, I plus plus, so this will loop only one time. We create a temp node, and that's equal to the queue.remove. So we go ahead and get rid of the 3 at this point. And then we have a temp node. We'll just call it temp. And this is our 3. And we make sure to add the temp node's value to the level. So we would add 3 inside of here. And then if temp node.left does not equal null, and it doesn't, we go ahead and add the temp node into the queue. So we'd add 9 into here. And then if the right's not null, which is not, it points to 20, we go ahead and add the right into the queue. And that would be our 20. And then it goes back to the for loop. I is now equal to the queue size, so it breaks out. And then solution not add level. So what that does is it adds a list inside of our solution list with the value 3. And then we go all the way back to the top, and we start at the very beginning. So level is now, it went out of scope during the first loop, and it gets created again. And this time it is just an empty list. And then queue size is now 2. So this gets, this is also deleted and created again. So queue size is now 2. And then temp is nothing right now. And then for int I is equal to 0, I is less than queue size is 2. So only loop 2 times. It checks the first value in the queue, which is the 9. So it removes it, and then it adds a 9 as the temp node right here. And then it adds the temp node's value into the level. And then 20 is now the next one up. And then it checks 9 if it has a left node, and it doesn't. And then it checks if 9 has a right node, and it doesn't. So nothing gets added into the queue for 9. And then it goes ahead and goes back around. It deletes the value inside the temp node, and I is now equal to 1. So it loops one more time for the 20. And then tree node temp value is now the 20. After the queue removes it, so 20 gets removed, the queue is now empty. Temp node dot left, it checks if it has a left or a right node, and it does. It has 15 and 7. So 15 and 7 gets added inside of here into our queue. And then 7 does as well. And then it breaks out of the for loop. I would now be 2 after the 20. And so queue size is now removed. Or 20 dot next. I forgot to add the 20 into here. So 20 gets added into the level. And then the solution dot adds this level list. So goes ahead and adds a list of 9 and 20. And then it will loop one more time for each value inside the queue, which is 2. And it creates a new level list. That's what this is right here. And it creates a new queue size, which is 2. And then it will loop twice. So it checks the 15, it removes it from the queue. So we can go ahead and remove that. And it stores the 15 node into the temp. The temp is now 15. Adds the value into the level list. It checks if 15 has a left or a right node, and it does not. So it does nothing. It loops back again. It removes 7 from the list. And then now 7 is now the temp node. Temp node, it adds the value into the list, and then it sees if it has a left or right node, and it doesn't. And then it goes ahead and breaks out of the for loop. The for loop ran twice. That's what the queue size keeps up with. And then it adds the level list at the end of the solution list. So it would add the 15 and then the 7. And then since the queue is now empty and no nodes were added for that last level, it breaks out of the while loop. So all of this will get deleted. It's all out of the scope. And if we go ahead and scroll down, this is exactly the list that it wanted us to return: the 3, the 9, the 20, the 15, and the 7. And that's just a nice little trace through the problem. But yeah, that's breadth first traversal. Depth first traversal is you go to the very end. Like you go, I'm pretty sure it's so breadth first is like you check this node and then you add these 2 into the list and you check those. Depth first would be I think you add each value into a queue until you reach a null, and then you go back and then you check the other side, and then you go back and then you check the other side. And breadth first is, I think it's just the in order traversal. If I'm not mistaken. I haven't done breadth first or depth first search in a while. But this is a good refresher. Get depth first search problem in there. It's a medium binary tree problem. I'm doing better than the easy problems I was doing all week. We can go ahead and check out the YouTube channel. See where we're at for today. I haven't checked it since yesterday. 170 subscribers. We're almost at 200. Pretty proud of that. Day 26, got 54 views, 155 views. I got a comment today about, if you go to your community tab, you can see all the comments. He said, yeah, Cooler TDW. He said, it'd be cool to see you work on hard problems across multiple days. I think that'd be interesting to do a pretty hard problem. Right now, we're just like kind of building up in the binary trees problems. I have like broken away and done a few array problems and other easy problems to kind of fill in the gaps when I've been super busy. But I'm pretty sure we'll probably do the zigzag level order traversal. It's very similar to the problem we just did tomorrow. and then we'll do a few more medium problems, and then the hard problems. There's not many hard problems for binary trees. If we go ahead and filter by difficulty hard, we can go ahead and see that there's just a handful to go through. So the binary tree cameras, that one looked pretty interesting. The maximum sum binary search tree, or maximum sum binary search tree in binary tree, that one looked interesting. Recover a tree from pre-order traversal. I'm pretty sure we're given the list, and we're given a string, and we have to build a tree from that. So that one might be pretty interesting. I don't know how that one would go, but it just looks like we build a tree and then we go back and back and back, and then we go to the next dash. I might be able to come up with a pretty decent solution for this one. But if y'all think I should go over, I've just been kind of trying to do one problem in one video. With some of the harder problems, if I get stuck on them, would y'all still like to see the me thinking through the problem before actually solving them? Or trying to figure it out one night and I don't get it, and the next night, do a bit more research and then figure it out before I come in. Because I'm kind of just make sure I understand the problem before I come on here and try to talk about it. But anyways, I think this will be it for tonight. Y'all, if y'all have any questions or comments, be sure or leave them down below. And I'm pretty tired tonight. I worked this morning. I was laying on the couch with the dog and my girlfriend over there. But tomorrow I'll probably do the other medium problem I was talking about. I think it's the zigzag in order traversal, or level traversal. And it's very similar to the problem we just did, except instead of going one level and then left to right on another, and a left to right on every level, it wants us to go left to right, right to left, left to right, right to left. So it's a bit more complicated. I think you would just have to, you would use the DQ. You could probably just use a DQ and go back and forth on it. Yeah, I think we could just use the DQ, and instead of removing from the first each time, we would have like a bit that would keep, or a a boolean to keep track of if we're going right to left or left to right, and based on that we would either pull from the back or pull from the front of the queue. That's kind of what I'm thinking. But I'll figure that out tomorrow and we'll make a video on that. But y'all stay blessed, y'all stay healthy, y'all keep coding, and I'll catch you on the next video. Hey Devs is out.